Welcome to Papa Junk Shop. Well, decided that I'm going to need a lithium iron phosphate battery charger, and was thinking I'd like to have 20 amps, but I know you need to have current and voltage control. So I gathered up some stuff and I got a plan. This is the rough draft on paper. Of course, you know, with my projects they can all change as we go along, but I figured on having utility power here and generator power here going into a double pole, double throw center off switch, and then I was going to have a relay, but I think that's already changed. The relay is built on the controller board, and the controller board will sense the battery voltage back over here, and we'll turn on the switching power supply, 24 volt 30 amp, which goes into a constant voltage, constant current module. And then we'll have an isolation diode, and then we'll have some metering. And I've got it temporarily hooked up on the bench here with a bunch of clip wires, giving it a trial run. And I got everything hooked up, and I've got just a little lawn and garden battery because it doesn't have a lot of capacity, and I can run it up and down quickly to test things. And 30 amp 24 volt switching supply, which is controlled by a voltage sensing module, and I have it set for at 11 volts. It'll turn this power supply on and charge the battery, and when it gets to 13.6 it will turn the charger off. And the output of the charger goes to a constant voltage, constant current module, which I have set for, I don't remember, I think it's 13.6, same as that. I had it up and down and all around playing with it. So, and it's supposed to be good for 20 amps, so I figured if I use 10 it'll probably work. But I want a 20 amp charger, so I'm going to have two of these, and I build a little rig here. I'll show you that a little better later. That'll hold two of these modules with a heat sink that used to be on a computer microprocessor. And this heat sink and the circuit breaker is for the output of the modules and isolation diodes. So I got an inverter set up over here, 250 watt load, and we'll watch this. Okay, I turned it on. You can watch the voltage drop here. Okay, just that quick. Of course, I've been running it down, and you can see it's charging 10 amps. And I'm going to turn that inverter load back off. You can see the voltage is coming up fairly quick. Got to 13.6 and shut off. Right away it come back on because the battery didn't have a chance to charge up. That's why I picked this battery, because it doesn't have much capacity. So I'm going to get a plan finalized for the case and get things wired up, and we can test it a little better. Well, now that I got all the parts gathered and had her hooked up, give her a test run on the bench with test leads. I'm going to try to build a case for it. I got the base laid out. Going to ready to bend it and drill some holes in it for some feet. Now I think I got the sheet metal all cut out and holes in it for the stuff. Still got to take it over on the brake and fold it up, but let's see, we got a ammeter that's going there. The controller will go there. Let's see, fuse there. Off switch there. Grid power in there, generator power there. 2 output leads. So I'm going to go ahead and get her bent on the sheet metal brake and squirt a little paint on it, and then we can start doing some assembly, I think. Got it painted and sitting in front of the heater. I think I'll call it a day. Give that a chance to dry so I don't mess it up on assembling it. Got the switch and supply mounted in the case, and I got the wires, all the wires attached to the controller, and got it mounted. Next I'm going to work on this heat sink that I got for the constant voltage, constant current module, and I figured extra cooling will extend the life of the thing. So this was off of a computer brain and it has a fan, which I have. It's sitting right there inside. It's tied in with the other fan on the power supply, so whenever this fan runs, that one runs. So the idea is that I've got a mount made here, and this is just going to drop in there like so, and then I'll tighten these screws down to hold it up against the heat sink. And from what I can tell, I didn't seem to get any continuity between things, but just to be sure, I'm going to put some of, I can do this one-handed. I've got some of this stuff for heat transfer, so I'm going to cut some strips, put right on there, and that will insulate it and make the heat transfer better. And at the present time, I've only got one of these. Actually, I got two, but one of them was DOA, so there's supposedly another one on its way. So for now, I can only mount the one in there. So that's going to be the next step, is get this mounted on there and some wires run. Okay, got the AC input side done. Let's see, it comes in the power cord on one side of the double pole, double throw, center off switch. And when it's on the grid side, it goes to the center, and from the center it goes to a fuse, and from the fuse it goes up to the controller, and from the controller it goes to the switching power supply. And the neutral side just goes directly to the power supply. And the generator side here, which I put a plug off a computer power supply, so I don't have two cords hanging out if I don't want to. That does the same, only on the other side of the double pole, double throw switch. So I know a lot of you are saying, well, you can just unplug it from the grid side and plug your generator in, but I might want to make a permanent install. So figured it's not going to hurt anything. So next, guess we'll go for the DC side of things. I think I got the DC side figured out, and I went over to find some number 10 wire for the output side, and I found this cable with a, I think they call them Anderson connector on them. That way if I want to, I can unplug it. I'll just have this on the bus bar, and I can unplug it and use it someplace else if I want to, without having to unscrew or mess around with it. So the battery side comes in, goes up here to the ammeter. From the ammeter it goes over here to a 30 amp circuit breaker, and the circuit breaker goes to the two diodes, which are blocking diodes, because if you hook this up, power feeds back through all this stuff, and there's no point in having it live, just wasting power. The only thing that does have to be hooked up is the controller, and this feeds the 12 volts over to the controller and the voltage sense. And the negative comes right directly off the constant voltage, constant current module, and I've only got one in there because, like I said earlier, the other one isn't here yet. That'll go right over here. So all I'll have to do is run two wires over to the power supply, wire up here to this diode, and add another wire to this lug, and then we'll have 20 amps. So I'll get her turned back over and we'll plug her in. I still got my lawn and garden tractor battery sitting here in the inverter, so we'll just go with that for now. Let's see. This is the positive side, and this is the negative. That should turn on the controller. Okay, so the battery's at 12.5. If I plug the AC in, turn it on, shouldn't do anything, and it didn't. So now if I turn my inverter on, and I think I got it set for 11. And it shouldn't take too long. I can put a little bigger load on there and bring it down quicker. While we're waiting for that, maybe I can show you how you set this thing. It's pretty easy. Just put a couple little buttons in there. Just reach in and hit that. This is how you set it. I got it set for 13.7. I can change it just by pushing that. We'll put it on 13.6. Go over here and hit it again. That's the low voltage. I got it set for 11. And this is just another part that I'm not using. And that goes back. So that's how you set the thing. And I think I picked there's like 8 different programs. I think number P3 is the one that is for voltage sensing. So let's plug in a little bigger load here. There we go. Okay. So it came on. It's charging 10 amps. Of course, the load I got on there is drawing about 20 amps. So I'll turn that back off and it gets up to 13 point, what did I have it set for? 6, 7? Yep, 6. Shuts off. Well, that battery's bad, that's why that come up that quick. Put that little load back on again. I've got it plugged into my kilowatt. I was going to see how much it uses while it's charging 10 amps. And I had this set up at a little bit higher voltage, and it did, when the battery started coming up, it did taper back some, so that'll be a good thing too, I think. It's like watching paint dry. I'll turn you guys off when it gets closer, I'll let you see. Okay, we're down to 11.1. Now it's teetering back and forth between 11.1 and 11.2. Gets to 11, it should kick on. Come on, you can do it. Well, it has to be below 11, so I think this thing rounds it off somewhat. Probably when it gets past 10.5 or 10.9, it'll switch. There we go. Yep. Right up to 10 amps. And it says we're using 205 watts. Let's see. Yeah, 205 watts. So we got 13.5 volts. 10 amps is what, 135 watts. So it's not exactly efficient, but as soon as I turned it off, it jumped right back up and shut off. So I think next I'm going to go get my jump box with that little 7 ampere-hour lithium ion battery in it and hook it up and see how it acts on that. Okay, I got the lithium iron phosphate jump box hooked up. It's at 13.3 volts. It's got a little inverter built in, so I'm going to plug a 90 watt bulb in it, 130 volt 90 watt, something like that, and we'll see how it acts. When we get down to the good part, I'll turn you guys back on. Okay, it's been on for a few minutes. We're only down to 13, so good battery makes a big difference. It's been 15 minutes and we're only down to 12.9. See you in a bit. Okay, it's been a half an hour. We're 12.8, 12.7. Can't make up its mind. Well, it was down to 11.3 and the inverter shut off. Turn it back on. See if it'll take her down the rest of the way or not. Nope. Okay, let me find something to run her down the rest of the way. I'm just going to reset this to come on at like 11.4. I think I'm going to take this up to 14.4. There. Okay, turn her back on. I put a smaller bulb in. Apparently those lithium batteries recover considerable. I say it's sort of like paint drying, watching paint dry, but that's how you find out if it's going to work or not. Okay, it gets to 11.3, it should turn on. And it did. I'll turn the inverter off. Alright. Charging 10 amps, just like I said it. So I also got an extension cord run outside, and I got my generator part plugged in. I thought I'd hook one of my little baby generators up and just see how it acts on the generator part. And the generator I'm going to use is this little baby Honda EX350. So I'll go get it fired up and set it outside, and we'll flip it over on generator and see how it acts. Okay, well, it's dropped down a little bit, like 8 amps or so. Let's switch it over to generator. Looks like it's doing the same. Yeah, didn't even move, did it? Flip it back again. Alright, makes me happy. Okay, I'm going to let her charge for a while and see how this reacts when it starts getting higher voltage. Well, it was charging there at stayed right at 13.7 and the amperage kept dropping. About 15 minutes it was down about 5 amps, and I thought, boy, it doesn't seem like it should be dropping that quick. And then I remembered I had the constant voltage set at 13.7 because I was playing with that lead acid battery, so I jacked it up to 14.4 so for this lithium. So I turned it back on. We're up to 13.9. We're still charging 9 amps or a little better. Probably a lot of you wonder why I'm using an analog meter. I don't know. I guess I like them. They don't require any power either, and a lot of these switching supplies and stuff, these digital ones, don't get along with them. They don't like the frequency they operate at or something. I run into problems that way. So I think the analog meters give more of an average, I guess you'd say. That's just my opinion. I don't know. So I'm going to let her go here for a bit and see what happens when we get near the end. Okay, it's been about 5 minutes. We're still at 14 volts, still at 9 amps. It's running on the generator part. I switch it over to the grid. You don't see any change. So apparently the switching power supply gets along okay with generator. And I did run my little temperature thing on there, and the let's see, the outside of the case is 66 degrees. The heat sink on the constant voltage, constant current module is 70 degrees. Switching supply is 69.7. So nothing seems to be creating any excessive heat, which is what I planned. So we'll let her go, see how she acts. Okay, it's been about a half an hour total. We're still at 14 volts and still at almost 9 amps. It's been another 5 minutes, so a total of about 35 minutes, and we dropped down to 8 amps, but we're still at 14 volts. Okay, 45 minutes, 7 amps, still at 14 volts. About 50 minutes, 14.1 volts, down to 6 amps. It's only been about a minute. We're still at 14.1 it says, but we're at 5 amps. It's been 55 minutes and looks like we're almost at 14.2. I think I just seen it switch there once, and we're at 3 amps now. I can actually see it dropping about 2.5. So it's taken just about, well, it's taken a little longer to charge it because it did slack off, but pretty similar charge and discharge times. Down to about 2 amps now, 14.2. I think I set that thing for 14.4. I don't actually remember for sure. Give her a little more time and we'll see. We're up to 14.4, still charging 1 amp. So as soon as that gets past 14.4, it should shut down. It's only been about a minute since the last time. Goes all at once, it seems. There she goes. Battery settling back. Alrighty, I think I'm a happy camper. It tapers down and it doesn't go over. And it doesn't get overly warm. Matter of fact, it didn't really get much above room temperature. Alright, well this is just about killed the afternoon. It's just about time for some victuals. So I think I'm gonna call it a day. See what it acts like in the morning. Well, my replacement constant voltage, constant current module they tell me is on the way. So I should be able to get this thing finished up as soon as it gets here. And I think it's going to work okay. Do want to check make sure my grounding is good for safety reasons. Make sure anything that's metal on the outside here is grounded. It appears to be, in case. If I check between these other pins, you don't get anything. Alright. And I did not put the ground pin up on this one from a generator because some generators are neutral is hooked to the ground and some aren't, so I'm just going to have it floating on that so I won't have a conflict. These are going to be the sides. I'll do them when I get the other part. Now they're going to be for ventilation. So they'll just go on there like so. That way I won't have any problem with ventilation. And if any of you are thinking about building one, just because I made it this way doesn't mean it's the right way. And I'm sure there are better ways of doing it. And if you're not comfortable working with electrical stuff, by all means, don't do it. Because it can be harmful to your health, we should say. But I got most of this stuff on either eBay or Amazon, and there's tons of these available on there. Just pick one you feel comfortable with, I guess. And same way with these voltage sensitive switches. See, this I think was 20 some dollars, like 27 bucks or something. And I think this was probably 6 or 7. Now I've got several of these that I use for my, one of my windmill, one of my water wheel, so that when the batteries get up and the voltage climbs up to a certain point, they just divert to a dummy load. And so I had spares, so I already had this, but thinking they were between 6 and 7 bucks. Real bargain, actually. And then the constant voltage, constant current module, there's a bunch of them out there too. They're all over the place. They're around 10 bucks. So it's not a real expensive item to build. And if you like building stuff, it's fun. But I ordered this stuff a while back. And in the meantime, Santa Claus brought me a NoCo Genius 10 amp charger with a lithium setting. So now I got two chargers that I can do lithium with. This is a 10 amper and this one will do 20 amps. And I was thinking about putting a switch on here, only running one module if I want 10 amps and two modules if I want 20, but I decided to just leave it at 20, especially after I got this. So I guess we'll call this a video. I'm sure you'll see it more in upcoming videos. So thanks for watching, and if you haven't subscribed, please do. And we'll see you next time.